All right, we're going to work on 1.2 now. Be aware this is going to be a little bit longer, so I'm going to go through the whole section in one night. You will have tomorrow to work on it, but the next day it's not going to be due for 2 days, but the next day we're going to do some in-class work on factoring and stuff with quadratics because it's such a big deal in calc. We need to make sure you have it down. All right. Linear and quadratic functions. Hopefully you have the linear side down. Hopefully you have it all down, really, but this will give you a refresher course and what you really need to know for calc. Okay. Should be familiar with that. That's the slope-intercept form. Of an equation where this is the slope, this is the intercept. Okay. We will work with that a ton this year. Believe it or not, it seems basic, but calculus uses it a lot. Okay. The slope m can be expressed several different ways. Rise over run, change in y over change in x, y2 minus y1 over x2 minus x1. And here's one you may not be familiar with. F of x2 minus f of x1. Those just correspond to each other. If you plug x2 into f, you get y2. Okay. Be sure you know when there's positive slope, negative slope, horizontal and vertical lines. Okay, positive slope up to the right. Negative slope down to the right. Then we have vertical line. The slope is undefined. The equation looks something like that. X equals c. It's just a constant. All right, and let's see if this one will actually show up. Yep. And this is horizontal. And that would be something like y equals c with 0 slope. Parallel lines, same slope. Perpendicular lines, slopes are negative. Reciprocals. So what that means is some slope 1 is equal to the negative reciprocal of the other slope. It also can mean if you multiply them, you get -1. Okay. So either of those has to work. This one would just mean those two are equal. Okay. In pictures, parallel and perpendicular. You're going to have to test for linear relationships. So let me just give you some real quick. Is the following function linear? Let's go with days and bacterial population. And we'll just put that in millions just for. Okay. Is that linear? Hopefully you can look at it and see that up 1, up 0.1, up 1, up 0.2, it violates the rules of a linear relationship. But if we want, we can do the change from here to here, y2 minus y1, x2 minus x1. So the y's over the x's. 0.1 over 1. That's the change there. For these two, we can see that it's not linear. These all have to match. If they matched, we would have to keep going, but we don't because they don't match. Okay, so we know that's not linear. It's actually an exponential model. In fact, population growth is very exponential. Just one other form that you'll want to know. We already addressed slope-intercept. Y equals mx plus b. Point slope is very useful sometimes. We've always taught it a little bit differently than the book. So m is the slope, but x1, y1 is actually a point on the line. So if I give you a slope and a point, you just want to plug them in. Perfectly legal. Okay, so write equation of a line with slope -2 containing 4, 1. So I have x1 and y1 and m. Done. Don't edit it. Editing that can just lead to algebra mistakes. The people at the AP with the test, they know what they're doing. They grade them properly. Okay. And we can also use general form. The slope here is equal to negative
We have a over b. The y-intercept is c over b. Okay. We won't use that very much, but it's there for you to know. Okay. All right. Quadratics. We've already seen this year with our data gathering with throwing the balls to each other. So this is a quadratic function. The graph is a parabola. Okay, so it's going to look like this, or like this. So know the difference there on the names. Quadratics have what we call roots, or zeros. There are several situations we can consider there. We can have two real roots. It can have one real root, or it can have no real roots. Okay, this is pretty important that you know how to find these. When we're doing area calculations and such, you'll need to know, because this will actually turn out a negative area, believe it or not. You'll need to know where this dividing line is so we can work with it. So how do we find roots? There are 5 methods. 1, graph. 2, quadratic formula. 3, complete square. 4, is square root. Can't remember the other one. So quick. Oh, factoring. Duh. Factoring is probably the default that you try first every time, just because it's easiest and fastest. Okay. But it doesn't always work. These two always work, so I'm going to probably push you to use those a little bit. This one is just not accurate most of the time, so you might want to avoid it. And this one is probably the least used in special situations. Okay, I have a few examples for you. Find the roots of x squared plus 2x. To do that, we have to set it equal to 0. Yes, I want you to write that down. It's very formal. On the AP test, they need to know what you're doing. I might know what you're doing, but those people won't because they're grading mass in mass. So write that down. This one can be factored. Remember, we need to multiply to get that and add up to get that. So 1 times 1 is 1, and 1 plus 1 is 2. Then we split it. We actually get that x is -1 on both of them. So we know that there's a root and in fact it's a double root at -1. We know the y-intercept is +1, and we know that it's symmetric, so we can graph it very, very easily. Let's see, 2x squared plus 3x minus 4. All right, we're going to use, I'm just going to show you the quadratic formula here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, this is a, b, c. X squared, x, nothing. Okay. So -3, 3 squared minus 4 times 2 times -4. This is 9 plus 32, I believe. We can stop there. Okay. We don't need to simplify. Most of the time you can just stop there. But if you need it to be a little bit easier to work with, the square root of 41. 0.403. So we have -3 plus 6.403 over 4. -3 minus. So 3.403 divided by 4.5. 1. Okay, always go to 3 in your answers. 3 digits. It's kind of an AP Calc standard. -9.403. So we have our roots. Okay. Completing the square. So we're going to solve that equation by completing the square. Okay. The first thing we have to know is that a must equal 1. All right. So we have to pull it out. 0 equals 4, x squared minus 3x plus 3/4. Beautiful thing is, if we divide by 4, it just goes away. It does not change our answers. Okay. Now we're going to take the 3/4 and move it over. And then I'm going to rewrite it with some spaces, because now we're going to complete the square. All right. Do you remember what goes here? It's b over 2 squared. B is -3. So I have -3 over 2 squared. I have to do it on both sides to keep the equation balanced. Now I rewrite it. This side I can simplify to 6/4. This side I can now factor. The thing we've done here is that these are always going to be the same. So it's going to give us a solvable equation. Notice though also that number is always the one that goes there without the squared, but it's that number. It's b over 2. Okay. So I have 3/2 equals x minus 3/2 squared, because there are 2 of them, so I can now square it. To solve, square roots, I get plus or minus and then my last step is going to be to add the 3/2. So 3/2 plus or minus the root of 3/2 equals x. Those are the roots of that equation. All right, one more item. Yep. Okay, the minimum of a quadratic. This is going to be there or there. So we have a min or a max. Yeah. One way to do this is using completing the square. I'm going to use the same one we used for the last example. When we completed the square, we found this. Okay. I'm going to move this back over.
and then make it a function. All right. So our minimum when x equals 0 is when our something's not right here. Sorry. When x equals 3/2, because that makes this term 0. So if this term is 0, that's our minimum. Okay. Or you can also note the vertex is 3/2, -3/2, just by vertex form. So our minimum here, because this is positive, it opens up, we know it has a minimum at that point. Okay, so that's one way. Another way would be to use the roots. So if I found that it was, oh, that's a bad one, but we factored, this is the first example from factoring, that this was x equals -1, so that we know that this is positive. X is -1, y is 0 is our minimum. Okay. Lots of other ways. Just quickly, if you find the roots, you know, right down the center of those roots is the minimum on the vertex. That's another way to look at it. I think that's enough for now. But again, you have 2 days to do this. Let me write down what I want you to work on. One, two. Oh, this is 1.2. 1, 2, 8, 10, 13, 16, 18, 23, 25, 30. 31, 33, 34, 43, and 51. Okay. You'll have tomorrow in class to work on it. Again, the second day it's not due, but we're going to do some factoring practice in class to make sure you have it down. Have a nice day.